Okay, so today I'll be talking about the MSA RAG chatbot that I've created and, the architecture and the thought process behind some of the design decisions. So, the purpose of this application is to provide the executive team at my school's MSA the ability to quickly parse through our Google Drive. Right now, we have a really big Google Drive, and being able to parse through that and find something specific is not that easy, especially when an executive knows what they're looking for but don't know where to look. It can take a lot of time out of their day. That's essentially the problem that this GPT is looking to solve. I'll go into the architecture behind the ingest, and then I'll show how the chat sequence works, and then we can see a demo. To index our documents and actually have that context, we can either manually trigger this process or we have a scheduled trigger that happens a couple times every day. Triggering this flow will start our GitHub action. So what's going to happen first is our service worker in this mock folder, you can see right here, is going to read all of the documents that we have, and then it's going to list all of our candidate files. We're also going to list our existing files that are already in this vector database. And then for each file, first we're going to check if it's a supported type. So that would be a Google Doc, a sheet, or a PDF. If it's not, then obviously we'll skip it. But if it is, then we're going to check has it changed since our last ingest. Again, if it hasn't, then we're going to skip it. But if it has, then we're going to extract the text from that document, and then we'll see does text still exist after normalization. If not, then it's going to fail. But if it does, then we're going to chunk this text, and then we're going to check have chunks created. If not, then again, that's a failure. But if a chunk is created, then we're going to use Gemini to create a vector embedding, and then we're going to populate our vector database with that embedding. We'll then increment our counter, and if there are no files left, then our ingestion is complete, ready for retrieval. So to see this in action, we can test that out. So here, if I move this cost per term sheet into our folder, I can move it in and then grant access, and then I can trigger a reindex. So here we can see that the index is started, and then I can check the runs. So looking at our logs for our ingest, we can see that we have 6 candidate files, but 5 of them were unchanged, so we just skipped them. But our new cost per term file was detected, and then we created the chunks, and then we have indexed that file. So now that file is ready for retrieval. So moving on to the sequence for retrieval, when the user makes a prompt and sends it to the chat, we can follow this sequence diagram. So when the user types a question and clicks send, we have our post endpoint that will send it over to our edge function. And then from our edge function, we're going to use the Gemini API embed content function to create an embedding of our question. Then in Supabase, we're going to use the match document chunks function to match the embedding of our question to any embeddings that we had of our chunk documents. And then these match chunks are returned. And then there are a couple different places where we can go. If no chunks are found, then we have a default response that I don't know based on the index files. It was an important consideration making this application that we don't want the chatbot to return any answer that's not in the training data. So as a result, we just complete that request, and then we have our fallback answer. If we do find chunks, then we're going to cherry pick those files that had the matching chunks, and then we're going to get the response of those file names and the web links. And then we'll also build the citations within our response. Then we have our streaming function to create a stream for the response. This, of course, is done using the Gemini generation API. Then we can show the stream response as it builds. Then we'll have our final markdown answer and then clickable sources, and we'll see this in the demo. In the event that we have any API, database, or model error, then we'll have our 500 response, and then we'll show an error message. So now that we've seen that our reindex was successful, we can come into this document and pick any column and expense. So let's say for fall 25, expense 4, we want to see how much it was, but we don't know where to find this document. We can just ask, what was expense 4 in F25? And the benefit of vectorization is that we don't need to say exactly, like I just said F25 is an abbreviation for fall 25, but it'll still be able to go through and pull out whatever information I'm looking for. So we can see that expense 4 in fall 25 was $300.13. And then we can see that we have our first citation as our source, which is the cost per term sheet. I do still have to work on the UI a bit, and that's why we have this document 5 coming up, but this wasn't cited anywhere in our response.